Okay, in this program, we're going to see how we can optimize our searching method if we know that the array is in order. All the values are in order from beginning to end. So this one will be randomized still. So we're going to include time.h. And then we're going to, of course, because we're doing some randomization, start with our srand line. Okay, now we need a couple values, so I'm going to make an array of numbers with 100 values in it. And we're going to have our search num here, but this one is going to be generated randomly. So the first thing that we have to do is we're going to load the array. And this is going to be in values that are going to be increasing as the array goes on. So we have to do something a little bit different for this. Before we do our for loop, I'm actually going to specifically set what the first value is. So I'm going to do this as a random number, modulus 2. So it's either going to be 0 or 1, just something to kind of get us started off. And then I'm going to write a for loop for the remaining. So for loop, now here's a change. Int I equals, I'm not starting at 0, I'm starting at 1. Because each value is going to be based on the previous value, there's no numbers position -1. So that's why I have to do this one a little bit differently. So we're going to go while I is less than 100. I++, and then we can put this in order. So what I want to do here now is I'm going to set numbers. I is going to get the value of numbers. Now if I'm referring to the previous space in the array, that is going to be space I minus 1. Now I don't want to make them the same value the entire way through, so we're going to add on a little bit of randomness. So random, we'll go modulus 2 plus 1. So it's going to just kind of grow a little bit as it goes through the loop. If you want this demonstrated, what I can do is I'll just, don't do this, I'm going to remove it in just a second, but I'll go through all of them and just to show you what our array will look like. Don't do this, I'm going to be removing this. So if I run this, here's what we get. It ends at 152, starts at 0. So you can see that every item is larger because all we do as we go through is we take the previous value and then add on a little bit extra to it. Okay. So as I said, I'm going to remove this. That was just to demonstrate what's in this array. Okay, so the next thing that we're going to do is we're going to randomize the search number. So search num. And I want to pick something that will usually be in the range here. So this is going to be a random number, modulus 140 plus 2. And those numbers should typically be in the range, although not always. I have seen one of these that ends at about 136, although that's rare occurrence. So let's output that value here. So search num. Okay, and then we're ready to start our searching. So the first way we're going to do this, we're going to set a counter variable that will kind of like exist outside of the loop because we're going to need to refer to how many times it took to find the number or not find the number. So we'll do the same one that we did from the previous searching program. So while numbers I does not equal search num, so we haven't stumbled upon the number, and I is less than 100. We have not reached the end of the array. We're going to go I++. Before we do this, of course, I should initialize I as 0. Okay, there we go. So now what we're going to do is if I is less than 100, so if we did not get to the end of the array, we're going to say, oops, cout number was found. There we go. Otherwise, cout number not found. The other thing that I want to do is I want to find out how many tries it took to find the number. So cout our counter I, we'll do an endl. So we'll run the program and see how many times it takes to either find or not find the number. So when it does not find the number, it takes 100 tries. The way this is set up, it should be about 50-50. Number not found, it went to 100. 100 again. Let's hopefully find one where the number is found soon. Not found. Come on. No. Of course, we're dealing with random numbers, so this can happen sometimes. Okay, here we go. So the number was found. 90 was found after in spot 61. So it took 61 tries to find 90. So if it found the number, it takes less tries than if it doesn't find the number. So what I really want to do is I want to optimize the part of the code that when it doesn't find the number. So I'm going to rewrite a different version of this. I'll do a little copy and paste here, and then I'll show you what the adjustments are. So go down a little bit. So now what I want to do is I realize, say if I've got a sequence of numbers that is 1, 3, 4, 5, 8, 10. Now, if I am looking for the number 7, here's what happens is in the first version, we go through all of them. We go 1, 3, 4, 5, 8, 10, didn't find it. So what I want to do is I want to realize, because it is in a sorted order, everything is in order from smallest to highest, I know that if I hit the 8, I know that I'm not going to find the 7 afterwards. So I can kind of go 1, 3, 4, 5, 8. Whoops, that's too far. I don't even need to bother looking at the 10 because I know that nothing after the 8 will be a smaller value. So what I want to do is I want to stop this if the number that I get is ever larger than my search number, or equal actually. So what I want to do is I only want to loop this as long as the number is smaller than the search num. So that means like if I've got 7 and I'm here, well, I know I still have to go further because the number would be smaller than my search number 7. And then also potentially because of the 140, and we know that the array can end lower, I do still want to keep this less than 100. Okay, so what I want to do now is I want to put a condition here to tell me that I found the number. So in this situation, if numbers I, so if it cut out of the loop because we found the search number, it'll look like this. So numbers I would actually still be the search num. So wherever the counter stopped, it'll be on the number that is the search num. So I want to do that the number was found. Otherwise, the number was not found. So this will cut out. So imagine that I'm looking for 7. And it goes 0, 1, 2, 3, 4. It says, oops, this is larger than what I'm looking for. So it cuts out of the loop. And then it goes down here, and it will not activate this. It'll go to the second part here. So now if I run this, let's take a look at an efficiency difference. Okay, this is where the second one is better. I was looking for 91, whatever the numbers were. In the first version, it took 100 tries to find out that I did not find the number 91. With the optimization here, it only takes 61 tries. So for every single time that the number is not found, it makes it twice as efficient. So here, when the number is found, though, no efficiency gain, 25, 25. But when the number is not found, let's find another one of those. Potentially, the difference between this number and this number could be huge. So we're going to be doing some work with sorting arrays later, but just by knowing that it is in a proper order, we can create a method that is much more efficient.